Well, my name is Scicchitano, and I'm a robotics and automation major here at Pennsylvania College of Technology. And what I did for my project for open house is I have an analog temperature control oven using this smart transmitter, a ControlLogix PLC on the other side of the bench here, and this Wonderware interface. So I can enter a set point of whatever temperature I want to control at, and also enter PID parameters here of how I want it to control at that temperature.
So 140 degrees is your set point.
Yep. And this is in Fahrenheit.
This is the live temperature reading here. Okay.
Yep. And then I have my process variable is what the actual temperature is at the moment. And I have an RTD in here, which comes into this temperature transmitter. And based on the temperature of whatever range I set it up at, from 70 degrees to 150 degrees Fahrenheit. So based on that range, it will feed 4 to 20 milliamps out of the transmitter and into my PLC. And from that, I do some math equations to display what the actual temperature is on the screen.
Right.
And same thing in reverse order from my set point. I enter a set point, do the math equations to get to the 4 to 20 milliamp range, and I feed that out to the light bulbs I have in this mailbox, simulating the oven to heat it to
and these lights are turning on and off.
Yep.
Cooking your Pop-Tart. So if I opened up this oven,
so I have a Pop-Tart inside here because I'm kind of hungry.
Yeah.
And I'm trying to heat it up a little bit, make it nice.
All right. So now what's happening here is the temperature.
My temperature decreased and it went off my graph.
Okay.
My graph here, I have it set up from 139 to 141 degrees, so you can see how closely it's really controlling to 140 degrees.
And once we close the door, you'll lose the heat loss, and this will start recovering.
And I'm still at an output percentage of 100%.
Which means the light's on all the time.
It's on all the time to try to get it back up to the set point temperature, and with the temperature in this, it's kind of a slow process, so it might be about...
It's slowly going up. Yeah.
Yep, I'm down at 133 degrees, and every couple of seconds I'm going up about 0.1 of a degree.
Now, where do you have your low temperature alarm set? I notice you have a...
I have a low temperature alarm if I go below 70 degrees Fahrenheit,
okay. So
which isn't going to happen.
Right.
That's lower than the room temperature in here.
Right.
Room temperature is around 75 degrees Fahrenheit. I have a high temperature alarm in case I go above 145 degrees Fahrenheit.
Yeah. Okay.
So my range is up to 150 degrees.
Yeah.
So I can read up to 150 degrees from this transmitter.
Right. I saw you're at 17.4 milliamps right now.
Right. So in my Wonderware development here, I set up here that I can only enter up to 140 degrees as my set point.
Right.
And I set that up so
Almost there.
if I set a set point at 150 degrees,
Right.
it's going to control around that. It will control slightly above and slightly below that temperature, and I can't read higher than 150 degrees from here. So my set point's 140, and I set this in my PLC program that if it goes above 145 degrees, I won't be within my range anymore. I'll be at my high temperature alarm.
All right.
And to read tags from the PLC to the Wonderware interface, it's called Kepler server.
Right.
Which can interface multiple softwares together, so I can make a nice user-friendly HMI screen here,
Right.
And now you're
to
back
control everything.
Yeah. Now you're back to where you belong, and the light's turning on and off now because now you're back in to your set point.
It'll be on 100% of the time if I'm trying to increase, and that also depends how far from the temperature will I start not being on at 100% anymore based on my gain.
Right.
And I set a proportional gain of 100, So it's within 1% of this temperature, I will start to not be on 100% of the time anymore and be on whatever percentage output it needs to be. And that I'm so high up on my range, I need to fluctuate around an 80% output to maintain a good control of this temperature.
Okay. All right, nice job.
Thank you.
I think your Pop-Tart's done.
It'll take a while.